Hello, I am the Programming Dunce, and in this video I will be introducing object-oriented programming and the class. This is a feature that differentiates between C and C++, as while you can program in an object-oriented fashion in C, it is explicitly supported in C++. C++ allows you to avoid using objects if you so choose, which differentiates between it and C# and Java, both of which require you to use classes. Even main has to be within a class in Java and C#. Classes, like structs, consist of multiple variables inside of it, but they also feature what are called methods. Methods are basically functions that apply to a particular object. Classes can have subclasses that extend the functionality or a feature. For instance, there could be a class called shape. Subclasses can include, but are not limited to, circles, rectangles, triangles, octagons, and so forth. I had to talk briefly about subclasses before talking about permissions. Classes typically allow 3 protection levels. Public variables and methods can be accessed from any code that has access to the object in question, or class, if said method variable is static. Private methods and attributes can only be accessed by the core object itself. Also, in C++, one object cannot access the private attribute methods of another object. Protected methods attributes are slightly more lenient than private, in that objects of a subclass can access them, but otherwise private restrictions apply. Objects come with what are called constructors. C++ also provides destructors, which are called when you delete an object. I have yet to see destructors in C# and Java. Also, in Java and C#, you would implement your methods inside the class itself. While you can do this in C++ as well, normally you would declare your class and method prototypes in a header file and then implement your methods in a separate C++ source file. In this source file, you would include the header file and in each method implementation, type the name of the class, 2 colons, and then the method. Those 2 colons are known in C++ as the scope operator. You use this to get inside a class or a namespace. I'll talk about namespaces later, but if you have noticed in previous videos, std::cout has the scope operator. Std is actually a namespace and cout is a declared object of type ostream. Anyway, these do allow you to access the private members, at least in Visual Studio. You are actually looking at a header file for the class type. I have a struct declared ahead of the class. The class demo class has a private pointer to demo struct. I have a couple of set methods and prep methods, as well as one basic constructor and a destructor, all public. Moving on to the CPP implementation file, we have the method shown with our internal code. We include the header file as well as iostream in order for the source file to work. The constructor creates a new demo struct, while the destructor checks to see if it is null. If the pointer is not null, then it is deleted. The various set methods take in data that correspond to a member of the struct. Each method checks to make sure the struct is not null before operating on it, just in case. The print methods also do a null check before printing the value of their respective variable. Now we go on to the main file. Notice how only the header file is included. We don't print anything directly from main. When you compile a C or a C++ program, the compiler will compile all source files. It is done up to a linker to ensure that the function or method call from one source file actually links to the function or method's implementation. It takes advantage of the fact that both source files include the same header file. In the main file, I simply declare an object of type demo class. I set the variable of the internal struct and call the print methods. Since this is the first video in the series that includes more than one file, I'll let you look at the main file for a few seconds. Then the implementation file will be shown again, followed by the header file. Thank you for watching, and the next video inherits from the next one.